46, head of streets. Actually, this problem is the same as the Leetcode problem 1296. So this is a divide array into set of k consecutive numbers. Yeah, let me use the description of this problem to explain it, because this description is more easy to understand. We are giving an array of nums, and we are also giving an integer k. So we're gonna check whether it is possible to divide this array into a set of k consecutive numbers. It's easy to understand. We can, make it to 1, 2, 3, 4, and 3, 4, 5, 6. It is consecutive numbers, and it is exactly two groups, each group with 4 numbers. So we're gonna return true. Otherwise, we're gonna return false for this example. Yeah, because there are only 4 numbers, but k equal to 3, so we're gonna return false. Now let's try to understand this problem. It's exactly the same. Just the description is a little bit longer. We have the group size and we have the head array, but exactly it's the same. So head I is the value written on the ith card at an integer group size. This is k. We're gonna return true if we can rearrange the card, so it is a consecutive becomes consecutive numbers. We're gonna return true. Otherwise, we're gonna return false. Yeah. Now let me try to solve it. This problem first, and then I'm gonna copy the code and try to check if it is the same, because here said the question is the same. Yeah. Now how can we solve this problem? We have to check the group size. So the group size is 3. If the length of the hand can be divided by group size equal to modular this group size equal to 0, it means we have to check if it is possible. If the length of the hand modular group size equal to a number, not 0, maybe 1 or 2, definitely we're gonna return false. Yeah. So let's check the false first. So n should be equal to length of the hand. So if n modular group size it is a number, we're gonna return false. Yeah. Now if it is not false directly, how can we check whether it is true or false, like the first example? So first of all, we're gonna starting from the smallest number and check one by one. So this is the greedy idea. We're gonna check, like, if the smallest number is 1, we're gonna check for the group size is 3. We're gonna check if there are 1, 2, and 3 inside its head. There is. So we're gonna take it out, and then we're gonna take the minimum number. It is 2. We're gonna check whether 2, 3, 4 inside. Yes, it is. We're gonna take it out. And then we're gonna check the smallest number. It is 6. So we're gonna check whether 6, 7, 8 inside. Yes, it is. And then the array should be an empty array. So this means we're gonna return true. Otherwise, for example, inside this array, maybe there is a let me make it. So maybe it is not 8, it is 9. Yeah. So for the last 3 numbers, we checked 6, 7, and next we're gonna check 8. If this 8 is not inside, we're gonna return a false directly. We don't need to check this 9 because it is not possible. Yeah. Now, how can we solve this problem? What data structures can we use to solve this problem? So we can sort the array. So the arrays will be in increasing order, but this check gonna be difficult. We have to check one by one, and for the next loop, it's gonna have maybe you have to use the 2 for loops. It's gonna be O(n) squared. It's not possible, and this n is 10 to the power of 4. It means we have to use n log n time. Yeah. In Python, we can use a sorted list. In sorted list, the numbers has already been sorted, but the AND and remove operation is only log n time. So we can use a sorted list to solve the problem. Yeah. So we're gonna put the hand array inside a sorted list, and then we're gonna check from the smallest number to the biggest number. For example, if we find a 1, so we're gonna check 1, 2, 3. If we find a 2, we're gonna check 2, 3, 4. If we find a 6, we're gonna check 6, 7, and 8. Yeah. Now let's start coding. So from sorted containers, import the sorted list. We're gonna use this sorted list as our basic data structure to solve the problem. Basically, this sorted list is similar like a balanced tree, but balanced tree is much more harder in Python. Now let's prepare the sorted list. Inside, we're gonna put the head. inside. It means all the cars will be put inside of the sorted list, and it will be sorted in increasing order. Now we are going to check the sorted list. Yeah. If there are cars inside, so while SL sorted list, so we're gonna check the minimum number, mn. It means the minimum. So the minimum number would be SL0. Now we're gonna use a for loop to check with the group size. So for example, the group size is 3. So for I in range, group size we're gonna check one by one. We're gonna check if this number, minimum number, if this mn is inside the sorted list. So the sorted list can remove this mn, and this minimum number would plus equal to 1, because we're gonna, for example, if it is 1, next time we're gonna check 2, and the next time we're gonna check 3. Yeah. If it is not inside, so for example, first of all, we're gonna check 1, and next time we're gonna check 2. If 2 not inside, we're gonna return false immediately. Finally, if we didn't return a false, we're gonna return a true. Yeah. So this is the entire code. It's not so difficult because we used the sorted list, and the time complexity is n log n. N is the length of the hand array, and this array is 10 to the power of 4. Now let me submit it to check if it works. As you can see, it works. It's not so fast because it is n log n. Maybe there's a better way to solve it. Maybe you can use on time, but I didn't find that solution. Yeah. So let's copy the code from this question to another question because it's exactly the same. Yeah. Now let me just delete these areas just to check if it is exactly the same. So for this problem, 1296 divide array in sets of k consecutive numbers. So let me take the import from the beginning and use the nums array. So here it is not hand, it is a nums array, and here we're gonna use this k. It's not group size, it is a k. Yeah. Now let me run it to check if it's exactly the same. As you can see, it also works. Let me submit it. Now as you can see, it also works. Although the time is not so fast, but at least it works because this is a n log n time complexity for solving the problem. For this problem, it is a little bit slower because this n is 10 to the power of 5. Yeah. But as you can see, the reading is lower. First of all, because this problem has already appeared before. So if it appeared before, if you solved this problem before, and now you're gonna solve it for the second time, of course the reading will be lower. And second of all, this problem, the description is really easy to understand compared with 846, and this reading is more than 1500, but that one is more than 1400. Yeah. Thank you for watching. See you next time.